See, large language models like ChatGPT, Claude, Gemini are incredibly powerful. They can write code, they can answer questions, they can summarize documents, and can even help with complex reasoning tasks. So naturally, people assume that they can answer any questions, but that's not true. Try asking an LLM about something that happened recently, or ask it a question about your company's internal documents. You may find that it either can't answer, or even worse, it confidently gives you an incorrect answer. Now, why does this happen? The answer lies in how the large language models work. See, LLMs are powerful, but they also have some important limitations. And before we learn what RAG is, it's important to understand these limitations of large language models. Imagine you ask Claude, who won the FIFA World Cup 2026? Now, Claude cannot answer that question without web search. Why? Because every pre-trained large language model has a knowledge cutoff, and it only knows what it learned during the training, and anything that happened after that is outside its knowledge base. For example, the latest news, today's weather, the current stock prices, or newly released products. Without retrieving the fresh information, the model simply cannot answer these questions. Now let's look at another limitation. Suppose you ask, what is Meta's HR policy? The model cannot answer that because it was never trained on Meta's private documents. The same applies to your company's documents too. Your Confluence pages, the SharePoint, the internal wikis, or your confidential databases. Unless that information is made available, the model has no knowledge of it. Now, another major limitation of LLM is something called hallucination. Sometimes an LLM sounds extremely confident while being completely wrong. When it doesn't actually know the answer, it doesn't say, I don't know. Instead, it often generates something that appears to be correct. And that's exactly what we call hallucination. So one of the biggest advantages of RAG is that it grounds the model's answer based on real documents, which significantly reduces hallucination. Now you might wonder, why not simply retrain the model with our internal document data? Well, imagine your company's HR policies are updated every week. Would you retrain a billion parameter model every week? Well, of course not. The training or fine training a large language model is expensive and time consuming and often impractical. So instead of retraining, you can simply use RAG to retrieve the latest version of your documents and provide it as context to the LLM. So no retraining is required. So what exactly is RAG? See, RAG stands for Retrieval-Augmented Generation. In simple words, RAG is a technique that allows an AI model to retrieve relevant information from an external knowledge source before generating an answer. So the workflow is actually very simple. So first, the user asks a question. The system then retrieves the relevant information from its knowledge base, and those retrieved documents are then passed to the LLM as context along with the user prompt. And finally, the LLM generates an accurate, context-aware answer. So here we are basically augmenting the generation process with the retrieved knowledge. And that's exactly why it's called Retrieval-Augmented Generation. Okay, now let's clear one of the biggest misconceptions about RAG. So many people believe that every RAG system uses a vector database, and that is simply not true. Remember, R in RAG stands for retrieval. And there are many ways to retrieve information. For example, you can use keyword search, you can use your SQL queries, or even you can fetch that information using your APIs, or you can use traditional search engines like Elasticsearch or vector databases. Now, vector databases are especially useful when you need semantic search. That is, if you want to search based on meaning rather than exact keyword matches. But if keyword search, a database query, and API can already retrieve the right information, then you don't need a vector database.
So remember this, not every RAG system needs a vector database.
The retrieval method should always be chosen based on your data and the problem you are trying to solve. However, if your application relies on semantic search, then vector database becomes an important part of the retrieval pipeline.
And if you want to learn about embeddings, similarity search, vector database, be sure to check out my vector database masterclass, link in the description below. Okay, now let's summarize why RAG has become one of the most important techniques in generative AI.
First, it gives your AI access to up-to-date information. It can answer questions about today's events, recent product launches, or newly published documents. Second, it works with private knowledge. Your AI can answer questions using company documents, PDF, Confluence pages, SharePoints, databases, or your internal knowledge bases without having to retrain the model. Third, it reduces hallucinations. Because the answers are grounded in retrieved documents, they become more accurate and trustworthy. Next, it's also cost-effective. Training and fine-tuning large language models can cost up to thousands or even millions of dollars. RAG avoids that expense by keeping the model fixed and updating only the knowledge base. And finally, RAG builds user trust. Since you can even provide citations of the knowledge sources used to generate the answer, users can verify the information themselves, and that transparency makes AI systems far more trustworthy. Okay, so let's quickly recap. Large language models are incredibly powerful, but they have important limitations. They have a knowledge cutoff, they can't access your private data, and they can hallucinate. And they are expensive to retrain. RAG solves that problem by retrieving information before the model generates an answer. So at a high level, the workflow is simple. Retrieve relevant documents, provide them to the LLM as context, and then generate the answer. And because the model is grounded in real documents, its response becomes more accurate and more relevant and more trustworthy.
In the next lesson, we will deep dive into the basic RAG pipeline. Thanks for watching and see you in the next one.